Okay, so this is day 6, I think. An art dealer, you might need a calculator for this. Just make sure you have one handy. An art dealer sold 7 paintings for the prices shown. Which measure best describes the typical price of the paintings? So, obviously, if we're talking about that, this is gone. One thing you can look at here is that there is this guy here that's kind of out of place, and that makes it the outlier, right? It's going to, if you take the average, that 280 is going to make all the other prices look that they're much more expensive. It's going to make the mean look much higher, therefore making it look that the average price of these paints is much higher than what they actually is. So I'm just going to do it 25 plus 30 plus 28 plus 35 plus 50 plus 280 plus 40. I gotta turn my calculator on. 25 plus 30 plus 28. Shoot. 25 plus 30 plus 28 plus 35 plus 50 plus 280 plus 40. Enter equals 488. Divided by 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Divided by 7. And it makes the mean, if you divide this by 7, it makes the mean 69.6. So it says here that the average price of these paintings is $69.71. Meanwhile, there's no painting that's even near that value except not even 280. Okay, so the mean is definitely gone. And because it has an outlier, we want to choose the median. Jenna listed the heights in inches of 17 of her classmates as shown below. Which statement describes the median of her data? So you would have to, they are in order, so let's find the median. So let's go from one end to the other. Cut one from this side, 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 one from this side. And keep working towards the middle. And here he goes. The median is 60. So the median is 18. Wow, what? Because it's the difference between the large and smallest numbers. Makes no sense. The median is 59.6 because the sum of the numbers divided by 17. You know that's not it. The median is 60 because half of the numbers are greater than 60 and half of the numbers are less than 60. And this is the one that we want. Mr. Benson surveyed his class of 30 students to determine their favorite dog breed. Right, so this is definitely, okay, the results were graphed using a bar graph. The longest bar was for Labrador retrievers. What statistics does this bar represent for the survey data? Well, it's not the range because you can't subtract a Doberman minus, I don't know, a Labrador or something. The mean, you can't because it's not, we're not talking about numbers, right? We can't add the dogs and divide the dogs by however many dogs, so that makes no sense. And the median, likewise, doesn't make any sense. Because how are you going to organize the dogs from least to greatest? So that doesn't make any sense. Garbage, 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 and you want the mode. Which one's the mode's the one that shows up the most. The line plot below shows the number of hours Travis worked each week during the summer. Based on the line plot, which of the following is true? The mean of the data is 25. So if the mode of the data is 22, the range is 14. So let's do ones that we can't. So to find the range, the highest is 30, the lowest is 17. So the range, right, this is the lowest number, this is the highest number. So the range is 13, so that's gone. And the mode is 22. The one that shows up the most is 22. Well, no, because there's only 3 values, so the mode is also not really. So this is garbage. And the mean is 21, the median. So now we can, I guess, line them up, right? So let me write 17. There's 117, 118, 24 times. 21 one time, 22. Actually, why am I doing that? So to find the median, I can just cross one from here, 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 and keep going, right? One from here, and we can literally tell that the median is 21. I didn't have to even line the numbers up. I could just use the dot plot as it is. So and I chose that, and I chose to do the mean last because I really didn't want to add all those numbers and then divide. So by doing the other way, by eliminating what I knew was not, I eventually got to the one that I wanted. Alex was taking a survey of which foods people like to eat with cheeseburgers. He found out that most people like French fries more than any other food. Which term should be which term should be used to describe this information? Well, it's not the average. Again, we can't add that. We can't line them up from least to greatest, and we can't find the range, so it has to be the mode, right? The one that shows up the most. Let's do number 7. Okay, so can I make this a little smaller? Okay, so I'll do the 7 in here. The line plot below shows the number of inches each student's height increased 1 year for 2 different groups of students. So 3 people grew 2 inches, 4 people grew 3 inches, 5 people, 1, 2, 3, 4, 5 grew 4 inches, and 3 people grew 5 inches, right? So, and the other one likewise. I'm not going to read it, but I want to read the question. Which of these following statements is true for the height increase shown in the line plots? Both the median and the mode are greater for group 1 than group 2. So the median for group 1 and the mode are greater for group 1. So let's just use the mode. So the mode for group 1 is 4, right? Because that showed up the most. And the mode for group 2 is 5. So we already can eliminate this because group 2 mode was higher than group 1. So that's gone. Both the median and the mode are greater for group 2 than group 1. Well, that's true for group 2, right? The mode here in group 2 is 5, which is greater than 4 over here. But is the median, I guess we have to find the median. So let me do this. Cross 1 from each side. 3. 1 here, 1 here, 1 here, 1 here, 1 here. 1 here, 1 here. So the median is 4, and the mode is 4. Here, the mode is 5, and the median, and we'll find that out in a second. 1, 2, 3, 1, 2, 3, 1, 1, 1, 1, 1, and the median in the bottom one is 3. So we can use that data for that. So both the median and the median and the mode are greater for group 2 than group 1. Are these two values, 5 and 3, greater than these two? No, it's not. That's not true. C, the median is greater for group 1. Yes, so group 1, the median was 4, and group 2, the median was 3, so that's true. But the mode is greater for group 2. Yes, and the mode is greater for group 2. So, did I say yes for no reason? Right, and then the mode is greater for group 2 because the mode in group 2 is 5 and the mode in group 1 is 4. So C is the correct answer for that one. Can I make it bigger? So what is this? Which conclusion can be drawn from the box plot? So this is the movie attendance, theater attendance on Friday and Saturday, and they did a box plot. So movie attendance, the attendance on Friday and the attendance on Sunday have the same median and interquartile range. Well, that's not true because the median is this and the median for Saturday is this, so they're not the same, so that's not true. The attendance on Friday has a greater median and an interquartile range than the attendance on Saturday. So on Friday the median is greater, so you can tell right here. The interquartile range, and I guess we have to do that. So the IQR here is this value minus this value, which I can't really tell what the values are. So I'm going to say no, only because I can't tell the values. I don't want to estimate. That looks like 500 minus about 410, 420. So when you can't really tell the value, that's probably a hint that that's not the answer. The attendance on Friday has a greater interquartile range than the attendance on Saturday. Both data have the same median. Well, that's not true because they don't have the same median. So that leaves us with D. So let's just confirm. So in D, it says that the attendance on Friday has greater median than the attendance on Friday has a greater median than the attendance on Saturday. But both data sets have the same interquartile range. So the median on Friday is definitely greater. And is their interquartile range about the same? Well, let me just see. So this is about 500 minus this value, which is about, I don't know, let's make it 410. Looks like the interquartile range is 90. Here, what is this value over here? Let's make it 560 or something. 560, maybe 570. And this is about 390. 490, I'm sorry. No, 390. Oh, shoot, what am I doing? This is about 370. This is about 3. Okay. Sorry. So that's about, let's start again. That's about 500. It is 500. Minus about 410. That should give me about 90. This one is about 470. Minus, and this is about 390. And that's about 80, right? But both sets have the same interquartile range. And a greater, so maybe I'll go back to B. So this doesn't look like it's true, but B looks like it's true now because the median on Friday was greater, so that's definitely true. And then it looks like this box here, right, is bigger than this box here. Not by much, but what do you call? By a little bit, okay, just by doing an estimation. So I'm going to choose B. Eight. Oh my God, these questions like that. Let me see if I can stretch this. I can't. Which box represents a set of data with the largest interquartile range? Ugh. So just by looking at this, it looks like this box here. So you want the biggest box, right? Because the interquartile range is the difference between this value and this value. So just by looking at it, they all share the same number line. So size-wise, this one. You can also obviously, so this would be a 29, this would be a 22. So 29 minus 22 is 7, right? This value minus this value. This one is 29 minus 25, which is 4. This one is 29 minus 25, which is 4 again. And this one is 28 minus 23, which is 5. So definitely, again, just the visual should have done the work here for you. Tanner created a box and whisker plot to use using his math and reading test grade. So math at the top, reading at the bottom. So let's see what we can see. If Tanner wants to compare his median grades, which of the following statement is true? Tanner's median grade is higher in math. Is this median higher in math? No, it's not. So I'm not even going to read the rest. Tanner's median grade is higher in math than reading. No, it's not again. Tanner's median grade is higher in reading. That's true because the box on the right is larger for his reading score than his mathematics score. Oh, yuck. Let me see what D provides us. Tanner's median grade is higher in reading the math because the middle mark inside the box for reading is higher than the middle mark inside the box for mathematics. That's definitely true. So this middle mark here, this middle mark, which is the median, is obviously higher than this. And whatever D said here, because the middle mark is inside the box range is higher than the middle mark inside the box for mathematics. So definitely this middle mark inside the box is bigger than the middle mark inside the math box. So definitely the answer is D. The box plot shows cell phone prices at two different stores. How much higher is the median price at store X and the median price store Y? Well, in store X, this is the median price, which is 45. In store Y, what's the median price? What is that number, 30? 30. It's greater by, so if you subtract those two, you get 15. Okay. 11. A movie theater recorded number of tickets sold for 2 movies each day during 1 week. Box plot to the data shown below. So movie X, this is how many tickets. Movie Y, this is how many tickets. Based on the box plot, determine whether each of the following statement is true or false. So let me just keep moving this up. A, the mean number of tickets sold for movie X is greater than the mean number. So I can't really do the mean. Remember what the mean is. Mean would be if you had a bunch of numbers like this. And you can add. It means your average, right? So you have to add all of them and then divide. So I can't do the mean on the box plot. So this one is false. The median number of tickets for movie X is greater than the median number of tickets sold in movie Y. That's true because this is the median for X, which is higher than the median for Y. So that one is true. The interquartile range of the number of tickets sold for movie X is greater than the interquartile. So you can just see it that the interquartile range is this box here, right? Is that bigger than the interquartile range for movie Y? Well, you can definitely see that it's true. So that is definitely true just by looking visually. And that's it. I thought there was more. 15. Sam will choose one coin from his box and record its value. How many different outcomes are possible? So, if you were to put your hand in this box without looking, your sample space, how many different outcomes, how many different things can happen? Well, you can get a 5-cent coin, a 10-cent coin, and a 25-cent coin. There are 3 different things that may happen. Okay, there are 2 types of light bulbs. There were testing conducted to see how long the light bulbs will last in their normal usage. The results were combined in the 2 box plots below. So there's type X and type Y, 2 different light bulbs. What percent of type X light bulbs in the test has a lifetime of less than 14,000 hours? So life, this would be, we're talking about X. So less than 14,000 would be from here to here. So this much lasted less than 25,000, less than 14,000. How much is that? Remember, your box is dividing 25% quartiles, right? 25%, and each of these is 25%. So how much of the light bulbs will last less than 14,000? 25%. So the answer for A is 25%. B, what are the 5 number summary statistics for lifetime in hours of light Y? So we want that the 5 points are, what are the 5 points needed to create a box and plot? So the 5 points were right here, 6, right? We needed this. We needed this, which is 12. We needed this, which is 17. We needed this, which was 19. And we needed this, which was 22. We have 5 points. Can you find the mean? Well, I'm going to stop right there. I can't find the mean, okay, using the box plot, because again, the mean would require me to find, to get all the light bulbs, right, and add them all their hours, and then divide by however many light bulbs were added. So I cannot find the mean. 16. The probability of 2 people in a given group of 13 having the same birthday is 15%. So probability that 2 people have the same birthday, if there's 13 of you in the room, is 15%. Based on this information, what's the probability of 2 people in any group of 13 not having the same birthday? Well, if the probability of having same birthday, if there are 13 people in the room, so probability that 2 people share the same birthday is 15. The probability that 2 people, I forgot to write 2 people, same birthday, and the probability that 2 people don't have the same birthday, right, would be the complement, right? So I'm gonna put an apostrophe here. I could have written 2 people same birthday was an apostrophe, which means of not having the same birthday is obviously the difference. So it'd be 85%, right? If the probability of something happening is 15, the probability of not happening is the difference between that number and 100%, if we're dealing with percent, which in this case is 100%. 85%. 100%, so 100% minus 15% is 85%. Well, the answer was D. There's a 2/3 probability that you will have math homework in math class. What's the probability of you will not have homework? So again, this is the, what do you call, complement. So the probability of homework is 2/3. The probability of not having homework, which is the complement, obviously has to be 1/3, right? Linda will use the spinners to form a 2-digit number. She will use the number the arrow on spinner A lands on as a 10-digit number. So you're looking for 2 numbers, right? So it's going to be, and she's going to use a number the arrow on spinner B lands on as the 1-digit. Lydia will spin each arrow once. What two-digit number is most likely to form? So if you spin this one right now, what's the one that has the most chance is the number 1. So most likely, the first digit here, the 10th digit, is going to be a 1. Now, if you spin the second one, what is the most likely number to happen? Well, there is 2 6, only 1 4, only 1 5, and only 1 7. So the probability of landing 6 is a little bit higher than the other one. So the most likely number that she might get here would be 16. Is that it? Oh, there's one more. Jerry tossed a penny 5 times. Okay. What's the likelihood that penny landed on heads all 5 times? Oof. Certain? No. Impossible? Also no. It is possible. Possible and likely? No. Possible and unlikely? That's the one. It is possible, but a very small chance of that happening. That's just it. Yeah, well, that's it.